friends, and welcome to Global Hack Week Security Machine Learning Edition. Or is it Global Hack Week Machine Learning Security Edition? I don't know. We'll have to fight it out. I am definitely of the every Global Hack Week is Global Hack Week Machine Learning persuasion. But we're doing security this time. We're doing machine learning plus security, a natural marriage, I guess. It's so good to see you. Adam, good to see you as always. OMG, it's Adam. MFOAD98, you are the second comment that I have noticed. So very up there, second place. ProF, hello. Thomas, hi, it's good to see you. So welcome to part 1 of 3. We are doing 3 sessions, and we made it easy for you. We're doing Monday, Tuesday, Wednesday. So if you stick around for the next 2 days, you can get all of this track. So I will do sort of the formal introduction and the formal kickoff, and then we will just get into some machine learning. So hi, my name is Will. I am a coach at Major League Hacking. I am also a software engineer at Google, where I do some machine learning-y things and some cloud things. Lots of fun there. I am a big Python enthusiast, and I drink a lot of espresso. That's basically my resume. And today, this week, we are going to be using machine learning to make our financial systems more secure by building a model that can detect credit card fraud. So what is credit card fraud? Well, I have a credit card. I have several credit cards. And if someone stole my credit card and then used it to buy something that I didn't give them permission to do, that would be credit card fraud, right? If someone got the credit card number on the dark web or something like that, and they used it to make a purchase that I did not authorize, that would also be considered fraud. And so we have some really interesting data. So if you are the credit card company and you're getting this data coming in, you probably are aware that sometimes they will block transactions, or they'll flag them and they'll say, hey, this looked a little bit fishy. But how do you make that call? How do you say, well, this transaction seems reasonable and that transaction is fishy? And that's what we're going to dive into this week. Let's see. Good night, Adam. Let's see. Question: can it still work with blanks? You will have to give me a little more details, but ideally we were building a robust model that if there was one value that we didn't know, that it would still work. So I guess without further ado, today we are just going to be doing a sort of gentle reintroduction to Python. So if you have never used Python before, if you've never used Python ever, it might be a little bit of a learning curve. But you can still totally hang with us. If you have done a little bit of Python, this is a great chance to kind of refresh yourself. So actually, in the chat, let me know. Give me a number give me a number 1 to 5, where 1 is like I've never heard of Python, and 2 is like I know what that is, but I haven't used it, and 3 is like I use Python like a decent bit. 4 is like I'm a Python pro, and 5 is like I am Guido van Rossum. I invented Python. Okay, we got a 6. We got a 6 out of 5. I love the enthusiasm. I would probably give myself a 4. I really like Python. Oh my goodness, so many rankings. Okay, so we're getting a lot of 2.5 to 3. I appreciate that specificity. We're getting a lot of like 3s and 4s, but also a lot of 2s. So this is a good spread. So hopefully in our little review of Python, I would say if you are a Python pro and you're like, I don't want to talk about Python right now, then that's totally okay. I would say please hang out with us because it won't be just learning Python. We will hopefully touch on a few things that are novel at the very end. I have my favorite things in Python edition that there might be 1 or 2 things that you haven't seen before, but we will just dive into it. If you're a 3, then that's great. That's sort of like a great place to be. And even if you are a 1 or a 2, we will bring you along, and you will know some Python by the end of this session. So the first thing I'm going to throw out there is this link to Kaggle. Actually, the first thing I'm going to throw out there is the link to check in. So if you have not checked in, go and get yo credit for being here. Boom. And then the second thing that I'll throw out there is a link to a website called Kaggle. So if you have done Global Hack Week with me before, you have probably used Kaggle. It is a really cool platform that lets people do machine learning competitions. So you are kind of, hey, we have someone checked in. Love to see it. you can basically participate in a competition where you build an AI and someone else builds an AI, and your AIs kind of fight it out. And usually this takes the form of trying to make predictions about something, right? So here we're going to be predicting, was a credit card transaction fraudulent? But it's also a really, really nice place to write code. So if you navigate to that link, we'll see if we can just punch in, boom. It should look something like this. And we will do a little orientation of Kaggle. So you'll see we have our overview, evaluation. Don't worry about this right now. If this just looks like a total mess, you're not alone. It looks like a mess to me as well. But we have the data. So we have some data on credit card fraud that we'll take a look at later today. But then importantly, we have code. And so a really cool thing in Kaggle is that you can write code and run it. And what's really nice is that all of our environments will be exactly the same. So we've tried this before where, we're all write code on my computer and tell you to write code on your computer. But our computers are different, right? And I have a different version of Python, and you have a different library installed, and you're on Windows and I'm on Mac OS. And so all of this is like messy. And so doing it all on Kaggle together, it's kind of like Colab or Jupyter Notebooks, if you're familiar. It just keeps things really simple. Yes, there is a Python intro session. So yeah, definitely attend that. And if you feel like you need even more refresher after this, you can get even more Python, which I certainly love. So to dive in here, and we'll talk a little bit more about like what actually the competition is. Also, let me know how the size is here. Hopefully that is visible. Also, this session is just all questions all the time. So like, let me know what you have questions about, what things are confusing, and we will just sort of follow the questions. So we have a list of notebooks here, and we have part 1. And if you click on that, you will see a bunch of stuff. But notably, you should see a button up here that says like copy and edit. And so this lets you grab a copy of my code and mess with it yourself. And so we can kind of have the exact same code, but we can edit it in different ways, but we're running in the same environment. And so that is what I'm going to do. If you click up here, you should see something that says copy and edit, and I will click edit, and it should look something like this. Give it a second. Cool. So this notebook is what it's called. This notebook is separated into individual cells. So each cell here is like a little chunk of code that we can write, or a little chunk of code that we can run. And notebooks are really, really helpful when you are a machine learning scientist, because you don't really need just one program to run all the way through, but you're going to be experimenting. You're going to be trying things out, and you're maybe going to go back and edit it and want to run it again. So notebooks are really helpful. But so for each of these cells, you can come over here and press play, and that will run that cell. So this code is about to execute. You can also do shift return, will also run that cell of code. So that's probably what I'll be doing, and you won't see me clicking play every time. But I'm going to pause for just a second. If anybody is trying to get to this kind of screen and they're like, wait, I'm not able to run the code, then let me know, and I can take a step back and sort of walk back through it. But hopefully if you go to that competition screen, which I should be able to get back to it here. So if you're on this screen, you should be able to go to code, this tab, and then click on part 1. And then click on this button that says edit right here. And that should give you the ability to, or your button will say copy and edit. And that should get you to the screen that I'm at, and you can be playing along. So Python. I love Python. I think Python is Python is my favorite programming language. And, in recent years, Pythons have gotten really big. I think it now is, it's like most new code written is in Python. But I was back there. I'm going to get very, very crotchety old man mode. I was back there when people looked down on Python. People said, Python is not a real programming language. Python's not serious business. But now Python is used for so much. And I think there are a couple really good reasons for that. Python is what we call a relatively high-level language. So you have languages like C and Rust. And those languages are really close to the hardware, right? You're pushing around individual bits on the computer. And then you have languages that are really high level, like Python and JavaScript are two examples that that you are not really, like messing with the hardware. You're not managing your own memory. You just get to be very expressive and kind of tell the computer what you want, right? And so Python lets you write really, really fast. It is also a really general purpose programming language. It is used in, everything from machine learning to scientific computing to a lot of stats stuff. To you can just build a web server in Python. Flask is like a great library for this. What do you think about the new Mojo language? I am not familiar with Mojo. Like, this is a language called Mojo. If you remind me at the end, I can look it up and we can have a moment. But yeah, so that's sort of my high level on Python, my high level on this high level programming language. So we're going to dive in and just look at all the basics and then build some stuff up to the point where we can do some elementary data analysis in Python. So each of our cells runs some code, and the sort of basic unit of storing data in Python, like most programming languages, all programming languages, is a variable. So we can create a variable of any name that we want, but it can only have letters, numbers, and underscores. And so you'll see a lot of variable names that kind of look like this. They have a word and then an underscore and another word. But you don't have to do that. You could just say this could just be called integer if you wanted, but I'll call it my integer. And then when we want to put things into our variable, so you can think of a variable kind of like a box with a name on it, and you can put something in there, right? And if we want to put something into our variable, we use an equals sign, which in Python is called the assignment operator. So we're saying, stick this number 6 into the box with the label my integer. So an integer is, of course, just a number with no decimal part. We can also do this with a floating point number, or we'll just call it a float. You can also do this for a string. Note that our text is in between quote marks here. So that's how we tell Python that it's a string and like not another variable name. And then we can also store something called a Boolean, which is just true or false. If you have done any programming, you are probably familiar with that. So then we can also just write our variable names at the end of a cell. And if you put something at the very end of a cell, Kaggle and Jupyter Notebooks in general will do this nice thing where it'll just show you what's inside those variables. So when we run this piece of code, we get 6, 16.5, hello, and true. So hopefully none of that should be a surprise, right? We put some stuff in the boxes, and then we looked in the boxes, and the stuff was still there. There's lots of fun stuff that we can do with numbers. So our integers here, we're assigning a letter, or a variable A and a variable B. And we can add them, we can subtract one from another, we can multiply using the asterisk, so like a star, or we can divide using the /. So if we run this, hopefully all of that is sort of what you expect. It's a build about Python, but on steroids. Allegedly 35,000 times faster. Interesting. We'll have to take a look. Later. So all of these numbers should make sense. We're doing math. One fun detail is that when we do division, even though we put 2 integers in, we get a float out. And you can tell it's a float because it's 5.0, right? Even though there is no decimal part, Python is telling us, hey, this kind of thing could have a decimal part. So just so you know. Another important thing, I guess there are a few others that we can throw in there. We can do a exponent b, or a to the power of b. And we can do that with a ** b. So what is that? 25 to the power of 5. That's going to be a really large number. Okay, there you go. 25 to the power of 5 is 9,765,625. 765,625. You can also do something called integer division. So we could say a int divided by b. And this is, if you don't want this to come out as a floating point number, you can just say, hey, force this to be an integer. So we could say a divide b. And if we put that over here, we get just 5 as an integer with no point 0. Which an interesting detail about integer division is that it will throw away whatever that decimal point would have been, right? So 25 divides into 5 evenly, but what if it was 26? This will change all our math. But if we say 26, we still get 5, whereas the float, it changes to 5.2, because 26 divided by 5 is 5.2. But when we do integer division, it's just 5, and it throws away that decimal point. We talked about using parentheses. So parentheses, they work just kind of like in math. You can use PEMDAS, and the parentheses come first. So here, of course, 12 minus 6 is, or 12 minus 6 divided by 2 is different than 12 minus the result of 6 divided by 2, right? Because in this case, this first turns into 6, and 6 divided by 2 is 3. But in this case, first you divide 6 by 2, and you get 3, and 12 minus 3 is 9. So we run that should look correct. You can layer as many parentheses as you want. You could come in here and you could say first 6 squared and then do all that. And so now you get, okay, 12 minus 36 divided by 2. That's a different number now. I would say in general, you don't want to use too many parentheses. If you have some expression that has like 7 layers of parentheses in it, probably that's just unreadable, and you should think about refactoring your code in a way to hopefully make more sense. Do we have any questions about variables or arithmetic? Hopefully that was not crazy. If you are like, hey, this is a lot and this is going by fast, let me know. Otherwise, I will probably speed up a little bit. But if you're feeling like, oh yeah, this is good, I'm getting it, but keep the speed down, then we can hang out. I think the goal might be to do maybe the first hour we'll do Python, then maybe take a little break, and then jump into actually getting to mess with our credit card data, which should be good. Okay, strings. We won't use a lot of strings this week. This is a very numbers-heavy machine learning project, but so we can put strings in variables, and we can also add variables together. So my name is Will, and I can say hello plus my name plus an exclamation point, and it says hello Will. Incredible, very fun. That's called concatenation. That's kind of a fun computer science vocab word. If you concatenate things, you're just kind of sticking them together end to end. But usually if we're doing something like that and we want to add a bunch of strings together, a lot of times we'll actually use what's called a format string. So format strings are, they're now in a lot of programming languages, but I think Python was one of the earlier languages to have sort of robust format strings. I know JavaScript also had them pretty early. But so I can have a variable, in this case, drink name, which is my favorite drink is a cortado, which is basically 50% espresso, 50% milk. So a pretty small beverage, pretty small, strong, small beverage. And so then I can make this format string. So it has an F at the very beginning that signals to Python, this is not a regular string. This is a cool string. The string has powers. And the power that it has is you can put curly braces, and then inside those curly braces, put a variable name, and then that variable name will interpolate into the string. That's another, strings get all the vocab words, concatenation.
Something went wrong. Try again in a few seconds.
My GOOGLE home just wanted to chat. Concatenation and interpolation. So interpolation is just when you kind of put something inside something else. So we're sticking a variable into our string. Another thing you'll notice, I used single quotes to create this string. In Python, you can use single or double quotes. So this is also a valid string. It now just has double quotes. But if you do single quotes and you have a single quote inside your string, you need to put a backslash. It's what's called escaping the single quote there. Because otherwise, if we remove that, Python would think that the string ends like right here, right? Because it's like, hey, you started the string with a quote mark and you ended it with a quote mark. Like, what's after? That's not part of your string anymore. So we put a backslash just to tell Python, hey, this is not to begin or end a string. This is just in there. SkyCloud asks, is this the same as the dot format function? Yes, absolutely. Or percent for string substitution. Yeah, so this is just sort of a nice kind of fun way to do string formatting. So another sort of classic way that people will do it is you could say, like if we copied this, you could put, instead of that, you could say just the curly braces without anything, and you could say dot format, and then you could put drink name in there. So this was drink name. Oh, I guess I have to actually run this code, don't I? So this accomplishes basically the same thing, and this is sort of the earlier way of doing this. You can also do string substitution, which is like really kind of a Python 2 thing. But yeah, lots of ways to put variable names into strings. So I just right-clicked here, and so you can delete a cell if you didn't really need a cell there. Delete it. So string formatting. We can also do logic in Python, right? So Boolean logic is trues and falses, and ends up being really helpful in all sorts of programming, especially machine learning. So I could create two variables, one called sunny in Seattle, which is false, which is just funny because it's actually sunny right now. It's very rare, but it's the summertime in Seattle. But go with me. Let's say it's not sunny in Seattle. And then we could say I want coffee, which is of course true because it's always true because I really like coffee. So now we can use the keywords and, or, and not to do sort of logic on these variables. So let's start with this first one, sunny in Seattle and I want coffee. Well, is both sunny in Seattle and I want coffee true? No, because one of them is false, right? So if you use and one of them is false, the whole thing ends up being false. And if we run this, we can of course see, yeah, that first one becomes false. Sunny in Seattle or I want coffee. That's basically asking, is either of these things true? And in this case, one of them is true. So I want coffee is true, and so the whole thing becomes true. And then finally, we can chain these together. So not just flips it around. So if it's true, it becomes false. If it's false, it becomes true. So if sunny in Seattle is false, not sunny in Seattle becomes true, and I want coffee is true. So if you take a true thing and say and a true thing, you'll get true again. So we get true down here as well. That's it for sort of our basic operations on our basic data types. Does anybody have questions at this point? It sounds like we do actually have like quite a few Python pros. So maybe this is all just like very basic review, which is good. It's good to good to get back to basics sometimes. Okay, I'm seeing not too many questions. Good deal. Then we'll charge ahead. So far, a question. What do in Kaggle? I'm asked for clarification. Is this like what is Kaggle used for, or is this like what should you be doing in Kaggle right now? Let me know, but I will check back in. I say Kaggle is mostly this platform for people to do machine learning competitions, but they provide this really useful sort of interface to write code and to run it, which is mostly why we're using it. Okay, yeah. So I will drop back if you are sort of joining now, I'll drop this link again. So this is ultimately we will be doing this competition where everybody tries to predict credit card fraud the best, and we see who does the best. And actually, there are 5 different ways that you can win swag in this competition, which maybe I'll share more at the end. But you can get swag for making the best predictions, making the best notebook, having the best conversation, or you could just win a raffle. So we're just going to randomly pick someone who submits to get some swag as well. So lots of opportunities for swag. But if you come here, if you just want to follow along, you can come and click on code, and then come and click on Python Crash Course. And then click on, for me, it's edit, but for you, it will be copy and edit. And so then you can jump into this little editor with all the code that I wrote sort of as prep, but you can follow along. And so you press a play button, it'll run that code. So now we're all the way down to lists and dictionaries. Blue Poison, I appreciate. I presume this is an ooh in reaction to the mention of swag. So I appreciate the engagement. So far, all of our variables just store one thing, right? But when we're dealing with a lot of data, we can't have a separate variable for every piece of data, right? We need ways to store lots of things in sort of one variable. And that's where lists and dictionaries come in. So a list is a really, really simple data structure that just stores a bunch of things in a line, right? So I could create a list called cities, and then you start with a square bracket, and then you put in all of the things separated by commas, and then you put another square bracket, closing square bracket. So this is now a list that stores two things. And if you want to add something to your list, you can call dot append. So you have the name of your list, and then a dot, and then append, and then inside parentheses, you put whatever you want to append to your list. So that's just a fancy word that means add it to the end. So if we run this, you can see we have Nashville, Boston, and Seattle, which are the three cities that I have lived in. We could append another one, like maybe someday I will move to San Francisco. San Francisco? I think that's right. And you can see our list gets even longer. So when we have a list, how do we check what's inside of it? We can use what's called indexing. And so we'll just have the name of our list and then some square brackets, and we'll put a number inside the square brackets. So a 0 means whatever comes first, and everything starts counting off from 0, right? This is one of those classic programmer things, is that you don't start counting at 1, you start counting at 0 and go up. And there are lots of reasons for that. Oh my goodness, Samrid, it's so good to see you. Samrid, welcome back. Samrid, I think you actually won. Is it possible that you won the first Global Hack Week that I was ever involved in? I think that's true. But definitely good vibes. Good to have you here. So for our lists, you can put the index of something in those square brackets and get it back. So Nashville was at index 0 because it was the very beginning. And then for index 2, we count 0, 1, 2, and that's Seattle. And then if we added another one and we said cities 3, that should give us the last thing. So lists. Lists are great. They just let us store data in a list, in one line of data. Another really useful data structure is a dictionary. So sometimes the data that we have doesn't really fit into a list. And if we have pairs of values, then we can use a dictionary. So a dictionary goes from a key to a value. And I think you can think of an actual dictionary as a pretty good example of this. So in a dictionary, your key is a word and your value is the definition of that word, right? So if you know a word, the dictionary will give you the definition. For this dictionary, we have city names and populations, which this is probably old at this point. But if we run this, we will see we get this handy dandy dictionary that maps cities to population numbers. So you can store different kinds of data. We can have our keys be strings and our values be integers. And then in order to get data out of a dictionary, you do kind of the same thing you did with a list, but you use square brackets and you put the key. So in this case, our key is a string. And so we can say, okay, give me the population from Nashville, and it'll spit it out for you, which is super, super helpful. One note is that the way you make a dictionary does look different. You use curly braces instead of square brackets. And then you do a colon in between your key and your value. If we want to add a key value pair, we basically just pretend like the key already exists, and then we use an equal sign to assign a value to that key. So here I can say city populations of Seattle equals 724,305. And then when we look at our dictionary again, Seattle is in there. We could also add, we could say, city populations and find, let's see, what is the population of San Francisco? 815,201. That was in 2021. So now you can see San Francisco's in there as well with its own number. Another handy dandy thing we can do is if you just want to get all of the keys in your dictionary, you can just say your dictionary name and then .keys. And that will give you it's like basically a list of keys. So we have Nashville, Boston, Seattle, and San Francisco. And the same thing works if you just want the values without the keys. You can say .values. Oh, not .value. .values. So here, this kind of doesn't have any context, right? Because we got rid of the keys. But you have all of the raw data that was in there as our population numbers, which sometimes can be helpful. Any questions about lists or dictionaries? Here's a fun bit of Python trivia. So in a list, everything is ordered, right? Everything has a specific order. The pop quiz is a dictionary ordered or unordered in Python? Answer in the chat if you know. If a list is ordered, is a dictionary ordered or unordered? Okay, so I will apologize. This was an absolute trick question because, yes, generally we think of a dictionary as being unordered. Technically, dictionaries in Python now do have order. I think it was Python 3.7. Technically, they got ordered. And then I think as of Python 3.10, that's actually part of the definition of Python is a dictionary is ordered. So just actually to kind of show this off, yeah, okay, leaving 03. There's a hash function that generates a number for them, and that by the order that they were actually added to the dictionary, they stay in that order. So if we actually come back and look, so we had Nashville and Boston, and then we added Seattle and San Francisco, and down here, that is the same order that they appear in. So I would say everybody who said unordered, you are basically right, and you shouldn't really depend on a dictionary being ordered. Usually, if you're depending on that, it's like not actually a good idea. But I thought it was a fun little Python trivia, and so now you can prank your friends by asking them if a dictionary is ordered in Python, because technically, as of Python 3.7, it is. But thank you for participating in this pop quiz. Okay, ifs and loops. So far we've learned how to store data in variables. We've learned how to do some stuff with that data, like add and subtract and do logic. We've also learned how we can store lots of variables at one time into one variable, so like a dictionary or a list. But so now what if we want to get a little bit more complex with dealing with that data that we've put into a dictionary or a list? So the first thing we'll look at is an if statement. You can also let me know how you feel about this in the chat. Does pineapple belong on pizza? I believe this is a true statement. So I am in this code cell saying pineapple belongs on pizza equals true. And now I can write an if statement that says, if that variable is true, do something. In Python, this is very specific. We put an indentation to show that this code sort of belongs to the if statement. So you write if, and then your thing that is either true or false, and then a colon, and then an indentation right here, and then whatever you want to do. So in this case, we're just printing out, I like pineapple and pizza, and I don't care who knows. You could also do some, you could do some random math. You could say x equals 2 plus 5, and you could print x if you wanted to. Oh, not capital X, lowercase x. So you can do anything you want in this cell or this code block, as long as you keep it indented in. Hey, yes, we have a pineapple lover. Love that. So that's an if statement. You can also do logic inside your if statement. So I'm actually not 27 or 25 anymore. I actually I turned 27 like a few days ago. So happy birthday to me. And at the age of 27, there are lots of things that I get to do now. For example, I can get a driver's license in the US, but I cannot say that I'm feeling 22 because I, in fact, am not 22. But so in these examples, we just check if my age is greater than 16, then that evaluates to true. If it's not greater than 16, it evaluates to false, and it doesn't run. So if we run this, we can see the first thing gets printed out because my age is greater than 16. But we don't print out, I don't know about you, but I'm feeling 22, because my age is not equal to 22. Another detail here is because a single equal sign is already used for assigning things, we actually use two equal signs to check to see if two things are equal. So double equals is actually the equality operator in Python. Oh, thank you for the birthday wishes. It means a lot, friends. Good deal. Which, okay, actually, fun fact, it was, which I think there's public knowledge. If you have attended many Global Hack Weeks, you've probably seen Nick Quinlan, who is part of like I forget what his technical title is now, because I think he's technically the CEO of MLH now that Swift is on paternity leave. But he got married this past weekend, no, 2 weekends ago. And so for my birthday, I attended a wedding and danced a lot, and it was a lot of fun. Thank you for the birthday wishes. Cool. So we have our comparisons. Hopefully all that's feeling comfortable. So now loops. So if I have a list of things, so here's a list of students. Actually, because we have some folks engaging, let's call some people out. Let's say in our list we have blue poison, And we have sky cloud. That's a fun one. And R2 R world. Boom. So these are the students. Y'all are not really students. We'll call them hackers. How about this? Okay, the hackers. And we can say, if I want to say I'm tired of saying hello to like welcome to the stream to everyone individually, I could say welcome to the stream. And so what this will do, so this is called a for loop. And so it basically just does something for everything in the list. So I'm saying for hacker in hackers, do this little line of code for every individual thing in the list. So if I run this, oh, not student anymore, it's hacker. If I run this using our format string again, then it'll run through, it'll say blue poison, okay, for blue poison, run this line of code. Sky cloud, okay, for sky cloud, run this line of code. R2R world, for R2R world, run this line of code. And so everybody kind of gets a turn having this code run. That is sort of the basics of a for loop, which we'll use lots of for loops. We can also use loops of dictionaries. So this is another one I have to update. So I'm now 27. My boyfriend Richard is now 24. Does that scan? No, he's 25. Oh my goodness, I'm a bad boyfriend. I don't know how old he is. He is 24. Okay, yeah. He recently had his 24th birthday. And Benjamin Franklin, I guess at this point, is probably 318 years old. So similarly, I could say, hey, what if everybody gets a birthday and everybody gets one added to their age? And so I can say, instead of for hacker in hackers, I could say for key in ages. So ages is the name of our dictionary. And so I'm just going to loop through every key in that dictionary and then do something with it. So I could, instead of actually updating it, I could say just like print key. And so we just get all of the names printed out and nothing changes. Or we could actually update the dictionary in this loop. And so we could say whatever the key is. So for Will, get the age of Will and add one to it. And then for Richard, get the age of Richard and add one to it. And for Ben Franklin, get the age of Ben Franklin and add one to it. Which I guess we didn't talk about this. This little plus equals operator just means actually add one to whatever thing you're looking at. So it's not actually like it says take whatever's in there, add one to it, and sort of put it back. And so now if we run this, we could see that Will is now 28, Richard's 25, and Benjamin Franklin is 319. Happy birthday, Ben Franklin. Lists are similar to arrays in C++. Yes. Yeah, I would say it's not exactly one for one. I guess in C++, the idea of a vector that sort of automatically gets longer for you when you want it to is maybe the best comparison. But yeah, the basic idea of a bunch of data sort of in a row is really the same, which is, yeah, definitely some similarities to arrays in C++. Yeah, and if you have any questions about, I don't know, if you have like a deep cut on like, I don't know, Erlang or Haskell or something, I might not be able to field it. But if you have questions about, about C++ or JavaScript or, or I don't know, whatever languages are out there, R, like happy to field those. Yeah, that was a great question. Great. Okay, so we've done loops and if statements, and we've done arrays or lists and dictionaries. And so now we can take a look at, now things really get serious. Now we become real programmers in Python, and we look at functions. So functions are a way to package up some code and reuse it multiple times. And we will do this a lot when we have a giant list of data, and if we want to do something for every instance of that data, it's much easier to just write a function and then reuse that function again and again. So there are a couple of key parts to our function. You started off by saying def, which just says, hey, Python, I would like to define a function. Then you use a name. So we name our function kind of like naming a variable, but usually you'll pick a name that makes sense for a function. Then you'll do two parentheses. And inside your parentheses, you can put any number of variables, or these are called arguments. So they are, whenever you want to use this code, what do you have to tell it? And then you'll use a colon, just like we do for all of our code blocks. And then you can add whatever code you want inside this little packet of code. And then at the very end, if you want to, you can return some value. So return just says this is what you get back. So the analogy that I like to use for functions is they're kind of like a recipe. So def just means I'm writing a recipe. My adding function here, that's the name of the recipe. Then in between these parentheses, this is kind of like our ingredient list. We're saying, hey, like if you want to do this recipe, you need eggs and flour and sugar, right? In this case, you need foo and you need bar. Then our body here is sort of like the actual steps in our recipe, right? It's like, okay, first add foo and bar together and then put them in a variable called mySum. And the last step is return mySum. And that return statement is really the finished product that you get to enjoy. So this is kind of a silly function, right? It just adds two numbers together. But we can call it, and okay, 2 plus 6 is 8, right? And that does work. So if you are writing a piece of code multiple times, then it's a good sign that maybe you could put that code into a function and then use that function again and again. Any questions about functions? Are you feeling good about functions? Of course you're feeling good about functions. Love that. Love that. If you have any questions, you know where to find me. Alrighty. So now we've tackled functions, we get to some big stuff. So libraries and pandas. So I mentioned Python can be a really fast language to program in because you can be really productive, right? It's not always the fastest language to run, but you as a programmer can just really get stuff done quickly. And one of the reasons for that is because there are so many really useful libraries. That's like a bunch of code that someone already wrote that you get to use. And usually that code is packaged into functions, right? Because that's how we reuse code in Python. So if you want to use a library, you'll use this statement called an import statement. So this just says, hey, that giant library called random, bring it in here. I want to use it. Then you can usually call what you'll do is you'll use the name of the library and then a dot and then a function from inside that library is usually how it works. So in this case, there's a random library that generates random numbers for us. And random.random just generates a random number between 0 and 1. So if we run this, we'll get a different random number. If we run this again, we get a different random number. And that's something that's like, okay, could you try to figure out how to write a good random number generator? You could, but that takes a lot of time. There's like a lot of math involved. You have to do proofs and stuff. And if someone's already figured out how to generate random numbers in Python, then I would love to just benefit from their work, right? So that's random. Random is actually a super useful one that comes up a lot. If you are not sure what's in a library, you can use a command called dir. So if you say dir and then parentheses and then the name of your library, you can see everything inside the library, but it can be kind of overwhelming. So if you run this, you get a giant list of all of the stuff inside of there. So you can see random is down here because we said random.random, but there's just lots of stuff. And so I usually wouldn't actually recommend calling dir. If there is a library that you are curious about, then I would simply Google it. So you could say Python random library documentation. And if you Google those, Python blank library documentation, you will probably get a pretty good response. So there's the official Python documentation that it can be kind of dense, but it's like very, very specific. And then oftentimes, W3 Schools usually is pretty good. They will have a lot of examples of how to use stuff. So, okay, choices. How does choices work? And here, boom, you just get a little example about how choices work. So those are my tips, my sort of very basic tips for learning about libraries in Python. Incredible. What now? Okay, another library that I imagine we'll probably use a little bit is called matplotlib. And it is just a graphing library. It's just a library that you can use to graph numbers. So we can say import matplotlib.pyplot as PLT. So a couple things going on here. First of all, matplotlib is a very big library, and it has a lot of modules inside it. So in this case, the library name is matplotlib, but the thing that we want is just called pyplot. And so we say matplotlib.pyplot, and so we're just importing the pyplot part. Now at the end, what we can do is because this is kind of a long name, we can give it an alias. So this is basically says, whenever I want to use matplotlib.pyplot, just let me call it PLT. And so PLT is a very common thing to call pyplot here. And so we could just use it. You can see later, we just say plt.plot instead of having to spell out the whole big name. So we can give ourselves some data here. We can do x and x squared. So you can see in this, we have a list of 0 to 6. And then here we have the square numbers, 0 to 36. And then we can just say plt.plot and pass it our two different series of numbers. And if we run this, we see we get this cute little graph, right? We can see, okay, yeah, 0, 0, and then 1, 1, and then 2 kind of jumps up to 4. And okay, yeah, this is basically a parabola, right? It's a pretty basic tool, but you can accomplish actually lots of really interesting things with it. We'll probably look at a few, I guess probably today as we're doing exploratory data analysis, we'll make some graphs and charts and stuff. Right on. Okay, so now we get to go to the pièce de résistance. PyPlot is called a method of matplotlib library. So the terminology that I would say that that PyPlot is a module inside the library that is matplotlib. Modules are kind of this fuzzy in between thing. So like library is the big category. A module is usually like a module is one Python file. And then you could say that plot here is really a method or a function from PyPlot. Yeah, it could get a little bit intense, but yeah, I think that's technically the correct terminology. Okay, so I know that, and now at the end here, it's like, oh, every next thing, I'm like, yo, this is actually the really cool thing. Get excited, right? But trust me, this is actually the really cool thing. Get excited, because we're going to learn about pandas. And pandas, I think, is one of the most powerful libraries in Python. What pandas lets us do is basically bring sort of a spreadsheet, like an Excel spreadsheet, into Python, which can be really useful for doing all kinds of data analysis, right? If you're getting into machine learning, data analysis is kind of your bread and butter, and pandas is really, really helpful. So again, here, we're going to say import pandas, and we're going to give it an alias of PD. That's another one that's very common. People will often import pandas as PD. And now we have some raw data. So pop quiz, what kind of data structure is raw data? Who can name that data structure? We learned about it just a few minutes ago. In fact, okay, I'll give you a hint. It's either a list or a dictionary. Hey, okay, yes. Okay, we're gonna do some callouts. Blue Poison, Thomas, Sassy, Gabby Rose, Sky Cloud, Fine, and Akai all got it correct. Yes, this is a dictionary. And inside our dictionary are keys, our strings. So these are sort of the names of our data. But then our values are actually lists. And what you're going to see in a second is us turning this dictionary of lists into what looks kind of like a spreadsheet. So if we create, we can say pd.dataframe on our raw data. So a data frame is kind of this spreadsheet sort of thing. And then if we call df.head, we get this cute little number. So this is sort of our spreadsheet inside of Python. So we have the column names are those keys that we put in our dictionary. And then the actual data in the columns is those lists that were our values. So if you look at it, it's kind of rotated. In our dictionary, our keys were all on the left, and then our data is on the right, and then you kind of rotate it. So now your keys are on the top as your column names. Your data kind of falls down below. But so look at that for a second to convince yourself that this makes sense. And so we have a list of states, a list of state abbreviations, we have a list of populations, and a list of number of Starbucks in that state. So just like you would do for a normal dictionary, you can pull out a single value using the key. So if I just want to pull out the number of Starbucks, then I can just say df and then the square brackets number of Starbucks. So this gets you sort of a single column from your spreadsheet. You can also do lots of cool statistical things on our columns. This is like where you start to see the power of pandas. So for example, you can do .mean on a column, and you can also do .standard deviation. So if you run that, you will see, okay, the average number of Starbucks in one of these states is 854, but the standard deviation is 826. That's a very large standard deviation. You can, of course, also do things like you can do .min and .max. And okay, the lowest one has 326, and the highest one has 2,821. You can also like loop through all the values in a column. So columns kind of work like lists here. So we could say df state, and then we could just say for every state in your list of states, let me have that and run this code. So we've got California is a state in the U.S., Texas is a state in the U.S., Florida is a state in the U.S., and so on and so forth. We can also use our columns as a graph in graphs. So if you remember up here, we had our two lists of x and x squared. Ooh, limeload, great question. What is .mean? So .mean just gets us the average value in here. So it basically adds up all the numbers and then divides by the length of the list. So mean and average are just the same thing. So it kind of gives you a sense of like what's a typical number. That is .mean. So earlier we had our two lists that we passed into the plotting method, but here we can actually just have two columns from our data frame. So here we can also, in matplotlib, you can add some labels and make your graph look pretty. In fact, we can also add like a title. So we're plotting population and number of Starbucks. We can also plot, we can also add a title. So this is number of Starbucks versus population. There's number of Starbucks in the state versus population. And you can see we get this cute little graph with a title and labels on our x-axis and our y-axis. And okay, yeah, you can see that, as your state gets bigger, the number of Starbucks in your state probably goes up. There's this interesting little blip here, which I guess that is what is the second smallest state in our list? We can go and investigate. I guess technically, I guess actually our data frame is a lot bigger than that actually. So we could say, let's see, let's give us the whole data frame, not just the top few. Okay, it looks like Illinois is a relatively small state, but it kind of punches above its weight in terms of Starbucks. Interesting. Huh. We can also filter our data frame. So if you remember, for our Boolean comparisons, you can take a number and then say it's greater or equal to some other number. But you can also do this with a column. So if we say df population greater than, I think this is what, 2 million? No, 20 million. We'll only see states that have more than 20 million people in them. So this, of course, gets us California, Texas, and Florida are big states. You can also create new columns. So you remember in the way that you create a new value in a dictionary is you just kind of pretend like it exists and then you set it equal to something. And you can do this in pandas as well. So we can literally just say, if we wanted to get people per Starbucks, so how many people, if you put everybody into a Starbucks, how many people would there be in each Starbucks? And so you can say literally population divided by the number of Starbucks, and you will get a new column. So we have people per Starbucks over here. And then you could also do some additional filtering on that new column. So what if we just wanted to do some analysis on states that have a Starbucks for every 30,000 people or fewer? So we could just filter based on the new column we added of people per Starbucks. So we can say people per Starbucks less than or equal to 30,000. And this actually gets a little bit weird. So we could then try to create a column saying that these people are highly caffeinated. But there's an issue. And the issue is that because Pandas is trying to store things in memory very efficiently, when you grab this filter here, it's actually just referring back to the original data frame in sort of a little bit of a magic way. If you're familiar with something like in C++, like pointers, it's kind of doing a pointer to the original data frame. And so when you try to edit that, it tells you, whoa, like you're trying to set new data on something that's just like a filtered view of something else, and this could cause problems. So if we want to clear this up, all we have to do is when we want to create a new copy, just say .copy at the end. So we're doing filtration here, and then just say, okay, give me a new copy of this data frame. And then once we have that copy, we should be able to set a new column on that new data frame very easily. So here we have our states with the most Starbucks per person, and they are highly caffeinated. Okay, cool. The timing here is great. So we are right at an hour, and so I think what we're going to do is we're going to do the bonus round of my favorite things in Python. This is maybe there are more favorite things that I'll add, but there are some cool Python features that don't kind of make it into the standard Python basics, but some things that I think are very neat. And then we will actually get our hands dirty and start looking at our data. So we won't. I don't think we'll actually build a model today. We might make a submission, but we'll actually start looking at what our data actually means. Okay, so favorite things round. I think I already looked at exponents. I think I showed you exponents, but the thing that is cool is that because the square root of something is just raising it to the power of 1/2, you get square roots for free as well. So if we had a number x equals 9, you can both get the exponent of that, so you can get x squared, but you can also, just by raising it to the power of 0.5, you can get the square root. So here our square root is 3.0, which I think is very fun. So you get square roots for free. There's also a thing called list comprehensions. So we did this thing, and I'll warn, like there's like 3 more cells, but the next 3 cells, if you're like, this is kind of confusing and I don't know what it means, don't worry about it. We're kind of venturing into a little bit more of the nerddom. So we know we have a list, we can have a list, and we can loop through that list to do something for every item in that list, right? So what if I wanted to square all of the numbers in this list? So I have a list called numbers, and the dumb old way that we would do this is you might create a new list called numbers squared that's empty, and you would just loop through all of your numbers, and you would say, okay, for number of numbers, take that number, raise it to the power of 2, and then append it to my new empty list, right? But the cool way, it turns out this thing of, oh yeah, I want to loop through the list and change everything just a little bit, but then have another list on the other end. This is such a common practice in Python that there is a special fun way to do it called list comprehensions. So what are we doing here? This is a list comprehension here. I'll run it and I'll show you that it works. So numbers squared, but cooler. We get our square numbers. We get 1, 4, 9, 16, and 25. So what's going on here? So this line right here basically it compresses these 3 lines of code just into a single line. So we have the thing that we want to create. So this is our declaration of a list. But then to do a list comprehension, we put it all inside square brackets, and then we just write what that loop says, right? So we say, okay, this is what we're doing for each number, and then you write for number in numbers. So here's kind of the thing, the little text for the for loop, and then here's what the value actually is, and it crams it all into this new list. So list comprehensions are fun. You can impress, if you do a technical interview, you can impress your interviewer by using list comprehensions. You can also do chaining comparisons. This is, I think, is actually not that recent, but this is not always true in Python. But now in Python, so in a lot of languages, if you want to compare 2 things, so like what if you want to see if someone is between the ages of 16 and 21. So this would be the age where you can drink, but you still can't, no, you can drive, but you still can't drink, right? And so in most languages, you could do something like this, where you just check, well, is the number greater than 16? And then you do a logical and for, is the number less than 21? And if both of those things are true, then you know that one number is in between the other 2. But in Python, we can just do this. We don't need 2 separate logical statements that we and. We can just say, if my age is greater than 16 and less than 21. And in both of these cases, our result is the same. I will say this one doesn't actually come up that often for me, but if you want to check if something is between 2 numbers, this is a great way to do it. Just chain your comparisons. I think, okay, yeah, this is our last option here. Our last fun thing in Python is negative indexing. So remember, normally if we have a list, so say I have a list of my ordinals, 1st, 2nd, 3rd, 4th, and 5th. normally something you can do is you could just index like 0, right? And you get the first thing, you can index 1, you get the second thing. But sometimes you don't know. Now, one way you could do this, if I told you I want you to get the thing at the very end of the list, something that you could do is you could say the length of ordinal. So we figured we learned how to take the length of something. So okay, it's 5 long. But you could say, okay, the last index is 5 minus 1, right? So you could say last index is equal to length of ordinals minus 1. And if I wanted to get the last ordinal in my list, I could do something like that, right? And we get 5th. But that's a little bit laborious. And if you just want to count from the end, this is a thing that is common enough that Python supports it natively, just with a negative number. So if you use a negative number as your index, it'll just say, okay, count from the end and count backwards. So if you say -1, that's 1 from the end, and that's 5th. And if you say -2, that's 2 from the end, and that's 4th. So negative indexing, this one is actually quite useful, and I think comes up all the time. So that is negative indexing. And because we just hit an hour, I'm going to take a brief break because I'm running a large piece of code that when it finishes, I want to jump on this. Okay, we're 87% of the way done, and apologies if I take another little break to download some data that I was generating. Good deal. Do we have any other general questions about Python? Or are we ready to get our hands dirty with some real data? Let's see, how did y'all learn practice writing more Pythonic code besides just using Python more frequently? Oh, this is actually a great question. I love this question. I think this question is incredible. So the main answer that I have is there is one book that I would really, really recommend called the Python Cookbook. Let's see if I can just find it. Yes, okay, Python Cookbook. Recipes for Mastering Python. So what I think is so cool about this book is it doesn't start with teaching you things about Python. It starts with, I want to do X, right? So it starts with like, this is something I want to do, and what's the Pythonic way to do it? Oh, look at that. There's just like a PDF. I'm not telling anybody to download PDFs of books off the internet, but it looks like this one's just right here. So I don't want to spend too much time on this, but okay, yeah, like this is a great example. The problem, you have n element tuple or sequence that you would like to unpack into a collection of n variables. So tuples are just a way of cramming, they're kind of like lists, but you can cram a couple things into one variable. And so it walks through, well, hey, here are different ways you could do it. And then it talks about like, well, this is a way to make this more Pythonic. So this is, I think, actually an incredible book that I would unabashedly recommend. I think you're totally right that obviously the more you use it, and the more you get code reviewed, the more Pythonic it will become. So I work at Google, and one of my favorite and least favorite things about working at Google is there's a very rigorous code review process, and part of that is a thing called readability. And so you're writing some Python, and you have to have both someone on your team sign off and say your code looks good. And you also need to have some random person that you do not know who really, really loves Python also say that they think your Python is good enough. And this, of course, can be stressful at times because they'll be like, oh, this should really be a generator instead of a function or whatever. But it's a great way to get better. And so if you do not work at a corporation that does readability code reviews, obviously that's not great advice. But I would say that having friends look at your code, and if you are so inclined, getting involved with open source projects where you are actually writing Python and having other people look at it and tell you if it looks right. This is, I would say, a really, really good way to do it. But that's kind of daunting. Have a friend look at your code and have them roast you. And also read the Python cookbook. But absolutely great question. Okay, so we are going to, I guess, switch gears and look at our actual data. So as I mentioned, Kaggle is this platform for machine learning competitions, right? And we have a bunch of data on credit card transactions, and some of them were fraudulent and some of them were not fraudulent. And so the whole idea around this competition is you are going to look at that data and try to predict if a transaction was fraudulent. So before we get too deep into that, we're just going to do what's called some exploratory data analysis to learn more about our data. But I think by the end, I will show you how to actually submit to the competition. Because if you remember, you don't even have to have a good score for submitting to the competition to have you win swag. Because one random person who submits is going to win some swag as well. Yeah, you are so welcome. Thank you for the question. I love that kind of Python question for sure. Okay, cool. So if you come back to our competition homepage, which I will drop the link to again, and you come over to data. So this is the data that we're working with for our competition. And you get a little bit of a description. And importantly, we have 3 separate files. So over here, you can see we have a training data set, then we have a test data set, and we have a sample submission. So you are going to have to submit something that looks like, if you want to participate, which, no pressure, but it's fun. You're going to have to submit something that looks like sample submission.csv. So it has the IDs of the transactions and whether or not you think it was fraud. So 0 for not fraud and 1 for fraud. And our training data set has lots of data in it. And importantly, at the very end, if we scroll over, the last column just tells you, is this fraud? So this is why this is training data, is because it has the correct labels, right? So okay, most of these weren't fraud, but oh, look at this one. This right here, this was fraud. And then so that's train. And then test is similar. It has most of the same data, except it doesn't actually have a label. So it leaves off that fraud column telling you if this was fraud or not. So why don't we, if we jump over to our code tab, come on, it's thinking about it. Oh, discussion loaded fast. Okay, code. So we did our Python crash course. We can jump into part 2, exploratory data analysis. So exploratory data analysis is called EDA for short. So if you hang out on Kaggle too long, you'll see people posting their EDAs, which is just their exploratory data analysis, or kind of getting to know your data before you start trying to solve a problem with it. So we will look at individual variables in our data set, and we will also look at relationships between variables. So this similarly, I would click edit or copy and edit if it's you. Boom. And actually, I'll push that back so that we get this guy. Okay. So there's another notebook that just has some different code in it. So we'll import right at the top our trusty friends, pandas and matplotlib. And then to make our graphs like 80% sexier, we will use this command called plt.style.use and then say ggplot. There are lots of different styles you can use here. And maybe we'll actually have fun and we'll try out like 3 of them. So that's just telling the library, hey, use some special styles for me. So here is our big line where we actually grab our data. So earlier we just had a dictionary that we turned into a data frame. But if you have a CSV file, so that's like kind of what Excel spits out. You can ask Excel to spit out a CSV file, which just stands for comma separated variables. You can slurp that up directly into a data frame. So this right here, this looks like a long path, but all I did is you can click over here and input. So this is the data that we give you in the competition. And you can grab right here, train.csv. You can just click copy file path. And that is what I pasted right in here. Boom. So then we can say df head. So df stands for data frame, and df head will give us basically the first couple rows here. And you can see we're in Python, and we have all of that data from the sort of original data set, from our training data set. Great. So now we're going to do, now we get into sort of like the trenches of machine learning engineering, because it is all about cleaning your data. And it's all about knowing what data type you have, right? So we have all of these columns. But if you look at them, you can see, okay, ID, that's an integer. Distance from home, distance from last transaction, ratio to median purchase price, those are all floating point numbers. So those are, like somewhere, so some random real number. But then our last five columns are all either 0 or 1. And so fraud is obviously just like a 1 if it's fraud or a 0 if it wasn't. But all of these are really kind of Boolean values, right? So we can tell our data frame to think of these values as Booleans by just using this function as type and then passing a bool in there. So we grab this column, repeat retailer, and say dot as type bool, and then we reassign it to that column of repeat retailer. So before we do all of these, if we just did this one, and we said df.head, you scroll down, you can see, okay, up here, it was a 1 or a 0. But down here, it's just true, 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 true. So Booleans can be a little bit easier to deal with if your data is in fact Boolean. So we're just going to do that transformation for all of those columns. And that'll help things be a little bit cleaner when we make some graphs. So actually, before we get too deep into here, maybe we jump back here and just look at, oh, that's not what I meant to do. And just look at, on our data page, we have some descriptions. So distance from home, the distance from home when the transaction happened, that makes sense. You might imagine the further someone is from their house, the less likely it is to actually be them, right? If someone steals your credit card information and they're on the other side of the world, like, yeah, they're not gonna go to your house to spend that money, right? Distance from last transaction. So maybe we think this is useful because it's like, oh yeah, if you're going on a trip and you're driving away from your home, it's like, well, you have a lot of transactions sort of on the way. So okay, maybe you're far from home, but if yesterday you bought something, a couple miles that way, maybe that's less fraudulent. We have a ratio to median purchase price. So this is the ratio of purchased price transaction to median purchase price. So I guess this is the thing this is saying is like, hey, if I always go to Chipotle and buy chips and salsa, and that's like $4 or whatever, and then someone steals my credit card and goes and they get 2 burritos and with guac on both of them, it's like, oh, that's suddenly no longer $3, that's like $20, and so if it's a much bigger price than I normally pay, then maybe that's a good sign that it's not actually me. Repeat retailer is this at a retailer that they have been to before. So, there are a lot of places that I do not shop. I do not shop at, say, Bass Pro Shop. And so if my bank sees, wow, someone just spent $2,000 at Bass Pro Shop, they know that's probably not me because I have never actually purchased something from Bass Pro Shop. More of an REI guy myself, Used chip, this is that sort of new security feature. I guess it's not new now, it's been around for like a decade. But the chip on a card instead of sliding it and doing the magnetic strip. Using a PIN number, so sometimes you'll be asked for your secret passcode that has 4 numbers in it, which maybe if you had to provide your PIN, maybe that's a little more secure. Whether or not it's an online order, we of course talked about location, but it's like, oh yeah, if you're just ordering from Amazon, you could be anywhere, right? And then finally fraud, which is the label. So we've just read through our data, and I think this is, it's kind of underrated, actually. I think just reading what is in your data and building sort of a domain expertise and understanding what your data means can be really important for when you're going to build a model later. Great, so now we kind of know what these columns mean. Let's look at sort of what their distributions are. So a distribution is just kind of like are there a lot of high numbers, are there a lot of low numbers, are there numbers somewhere in the middle? And a univariate analysis just means we're looking at one variable at a time. So we wrote some code here where if you do, so df columns just gets you a list of all of the columns. So you can see ID, distance from home, all of those, right? And because we want to look at everything except for ID, we could say, we didn't actually look at slicing. So maybe I'll talk about slicing real quick. But slicing is just a way to get part of a list. So say I have a list, my list, and it is equal to 1, 2, 3, 4, 5, 6. If I just want to get the last 3 numbers, I could say my list, or what if I just want to get the first 3 numbers? I could say my list : 3. And so this means I'm going to get all the way up to index 3, but not including it. But what if I just wanted to get things after the first thing and before index 3? Well, I could say 1 to 3. So this gives you, 2 and 3, the things sort of between index 1 and index 3. So slicing just lets you get a portion of a list. So in this case, I just want to leave off the first thing. And an easy way to do that is to do columns with that slice and say, hey, start at index 1 and just get everything else. So now I'm going to make use of the data type of a column. So the way you're going to visualize data is going to be different depending on what kind of data it is, right? And so every column has what's called a data type. So here, if we looked at, okay, repeat retailer, and we said df repeat retailer, and if I said dot b type, then I would get, of course, come on, it's thinking, bool. Which, if you remember, of course it says bool, because up here, we actually explicitly said, repeat retailer, make sure that's a Boolean, right? But what if we look at one that we didn't actually pick? What if we say distance from home? We say distance from home dot b type, and we'll see that is, of course, a float. Technically, it is a float 64 because 64 bits are used in memory to store that float. But it's a floating point number with a number with a decimal part, right? So if we're doing our analysis, we can say, okay, I only want to look at columns that have floating point numbers in their data. So then plt.figure just means is just telling matplotlib to create a sort of visual canvas for us to write on, and fig size just controls how big it will be. So we can play around with that. You can see how it changes size. Then we can add a title for each graph. And then we're going to make a histogram. So a histogram is a great way of showing you what a bunch of individual values look like all together. And so I'm just going to run this, and we can see what this looks like. So for a histogram, if you're unfamiliar, if you didn't cover this in stats class, on the y-axis, you see how many times something showed up. And then on the x-axis, it's what the number was. So if you look here, this looks like it's about like 0 to 7 or something like that. Maybe less. Maybe it's more like 0 to 6. But so we have like almost, it looks like 9,000 people or 9,000 records that were somewhere between 0 and 6. So this makes sense that like most of your transactions are pretty close to home, right? And if you go out and you're like, okay, around 10 miles, only 4,000 transactions in our data set are about 10 miles from home. If you go even further out and you're looking at 20 miles from home, yeah, that's like basically like only 1,000 transactions that are 20 miles from home. So this gives us just kind of a general sense of, okay, yeah, like most transactions are close to home, right? Which is cool. And because we did this in a loop, we're getting this for all of our columns that have floating point data in there. And you could mess with this if you wanted. If you felt like that was a little bit too tall, you could change it to 8 by 2. So it makes it, a little bit stretched out like that. We can scroll down. Distance from last transaction. So this is, I think, actually really interesting. So there are lots of not lots of transactions, but there are plenty of transactions that were 30 miles from home, right? But there are not a lot of transactions that are, more than 10 miles away from the last transaction, which I think is just sort of a super interesting observation here. Okay, what about ratio to median purchase price? That we see like a pretty similar pattern that it's like, okay, yeah, do you occasionally buy something that's 5 times what your average purchase is like? Sure. But you almost never buy something that is 10 times as expensive as the thing you normally purchase. So we see kind of a similar drop off there. So those are our 3 floating point variables. And we have kind of a sense of what that data looks like now, right? For the cases where it's Boolean, we can use a bar chart. So maybe we make this squat as well. So this right here, so we're saying if our column is a float, then we'll do a histogram. But if our variable is Boolean, then we'll just do a bar chart of how often is it true and how often is it false. So if we run this, we'll get some of the same stuff. So those first 3 are the same. But then repeat retailer, we can just see just a bar chart of true and false. So usually it's a repeat retailer, right? That makes sense. And this is interesting. Usually people use chips, but not always actually. Not it's maybe that looks like 2 to 1, or maybe 3 to 2 or something like that. Or no. It looks like about 2 to 1, yeah. Or maybe like 5 to 2. Used pin number. This is also interesting. People almost never use their PIN, which now I think about it, it's like, oh yeah, like I don't even think I have a PIN number for my credit cards, which maybe I should. I don't know. Please don't do fraud on me, y'all. I know I'm putting a lot of ideas into your heads, but yeah, I'm a good person. Don't steal my credit card information. Let's see. It's getting a little bit dark in here, so I am going to try to. Oh, I do not need to update my light. Come on, lamp. Oh, it was just off. Okay, maybe it will turn on now. No, maybe not. Use PIN number, online order. Okay, this is also interesting. Most of our transactions in this data set are online. I'd be curious to see if this is true sort of in general, because it might be that our data set tends to skew towards online orders. And then finally, fraud. So this is, I think, probably the most important univariate graph here. Most of our transactions are not fraud, right? And if you think about it, it's like, this just makes sense that it's like, yeah, like most people using credit cards most of the time are like not trying to do fraud, right? Like usually people are just behaving themselves, and fraud constitutes this really sort of small percentage of the bad outcomes here, right? So this is what we call a classic unbalanced data set, or an imbalanced data set, because there is the thing we're trying to predict. There's way more of one kind than the other, and this is going to be a problem that we're going to run into. So we'll have to take a look at that. Okay, so now we're going to jump into some bivariate analysis, and this lets us look at multiple variables at once. Specifically, it lets us look at the relationship between two variables. So one thing that we could do is, I'm trying to think if we want to do like a simpler version of this. So correlation, and the correlation coefficient of two values basically just tells you if they move together, right? So if two things are really positively correlated, then that means when one goes up, the other also goes up. So a sort of classic example of this would be like square footage and the price of a house. As you add more square feet to a house, it usually goes up in price, right? Like, yeah, is it going to be like 1 for 1? It's not like every square foot gets you $20 more or something, but usually those things kind of move together. Whereas like a thing that moves opposite is number of cigarettes you've smoked today or smoked daily, and your life expectancy, right? The more you smoke, the shorter your life is going to be usually, right? So that we would say has a negative correlation. So we can use this number of correlation to tell us sort of how much two variables influence one another. SkyCloud asked, how do we show it as true false on the x-axis? That is a great question. So I believe so you can do just a regular bar chart, but if you go through pandas, so here I actually just grab the column and do what's called value counts, which honestly, value counts is kind of an underrated function. Maybe I'll just show you how to use that really quick. So if we grab a column, let's grab, what was it? I guess just fraud. If we grab fraud and we say value counts, then we can get a little readout of there are this many trues and this many falses. So we have a lot of trues and not that many falses. You could also pass a parameter called normalize. We discussed that it's true. It'll give you percentages. So we could see 91% of our data says false, not fraud, and 8% of it says true, it was fraud. So once we have that value counts dictionary, then you can say dot plot on it, and then say kind of plot you want to do is a bar chart. So if you do that, you should get those labels on the bottom. Great question. You can do it just this normal way with plt.hist, but that is it's a little bit circuitous. So yeah, univariate analysis, bivariate analysis, correlations. They let us see how much two things interact with one another, right? So if we scroll down here, so we're getting rid of the ID because ID is not really a number that we expect to correlate with anything, right? But if we grab everything but our ID and we do .core on it, so if we just actually, before we do the fancy visualization, before we look at the fancy heat map, just look at what this spits out. So this spits out another data frame of correlations, right? So one thing that you can see is every column name is in the row and the column. And if you're looking at yourself, your correlation is always 1, right? Distance from home always correlates 1-to-1 with distance from home, right? Like if you're 2 miles further away from home, you are always 2 miles further away from home, right? But if you look off, so that diagonal is always going to be 1s. But if you look off the diagonal, you will see these numbers that are usually pretty small, but they are correlations. So one super interesting one here is repeat retailer and distance from home correlate. So that's actually interesting. Now I'm thinking about that. Repeat retailer and distance from home correlate. I'm unclear if this by default is like if true equals 1 here. I would guess it does, but this would mean that you're more likely to be at a repeat retailer if you're further away from home. And at first, my thought is like, that seems kind of not right. That seems kind of like you wouldn't expect that. But then I think about when I travel, and it's like, oh yeah, when I'm in Seattle here, like I'm always trying new restaurants. A lot of times if I'm like on a road trip or something, I just want to go to Chipotle. I just want to go to Starbucks or whatever. So maybe there's some truth there. But it might just be saying these things are like because you're a Boolean value, you don't necessarily have like an up direction and a down direction. That might be something to check. But this is a lot of numbers. It can be kind of hard to read. And so we can pass that correlation matrix into Seaborn is another library that uses matplotlib under the hood. And we can say seaborn.heatmap to give us a pretty neat correlation matrix heat map. Boom. And so you can see this. The darker it is, basically the more two things are correlated. And you can see we have a little heat map here. So 0 is basically there's no correlation between these things. If you're really dark blue, that means you're really correlated. So you can see the diagonal really easily here. You can see, of course, that repeat retailer correlates with being far from home, we think. That might be flipped. And then you can see these smaller ones, which interestingly, the heat map I don't think is actually that helpful, just because like most of these are pretty close to 0, right? So we have a lot of really weak correlations. But one thing you might look at is you might look at the fraud column right here, because ultimately we want to see, well, what correlates with fraud, right? If we're trying to predict if something's fraud, we have to care about what you're actually what the numbers have to say about whether or not this is fraudulent. And so you can see we have a lot of really small positive correlations. So the further you are from home, at the margin, you're a little bit more likely to be fraud, right? Which kind of makes sense. If someone steals your credit card or your credit card number, they could be on the other side of the world, right? Distance from last transaction. Okay, yeah, if someone's really far away from the last time you used your card, there's a little bit of a positive correlation. Now, 0.01 is a really, really faint correlation, right? It's certainly not 1-to-1. And you can go on and go so forth. Interestingly, used PIN number, that's negatively correlated, right? And this makes sense because like if I used your PIN number, then I probably if I know your PIN number, I'm probably authorized to use your card, and that's probably not fraud, right? So that's like a good example of a negative correlation there, kind of meaning something. And then of course, fraud always correlates with fraud. Let's see. Oh, dist plot. I think I was a little bit off the trail here. I don't actually know what I was doing here. Let me delete that cell. So we've explored our data and we know a few things that correlate, right? And so one thing we might look at is just actually splitting our data, because we know distance from home correlates with whether or not you're fraud. And so we might actually look at, well, hey, can we split up our data based on what's fraud and what's not, and just look at like what's the average distance from home if it's fraudulent, and what's the average distance from home if it is not fraudulent. So we could basically do a filter of our training data and then take some means. So we have, I think it's just called df. We could say df fraud. So this just gives us a bunch of true and falses and fraud. And if we wanted to say df fraud, then we could basically say, get me all the rows where fraud is true. And so now, if we look at this, and we do df fraud head, you can see if we scroll over, all of these are fraud. So we just sampled out just the examples that are fraudulent. And so now, because we saw from up here that being far from home just a little bit correlates with being fraudulent. So what if we said df fraud, and we just said df fraud distance from home dot mean. So of all of our fraudulent transactions, the average distance from home was 10.2 miles. Okay, now let's do the same thing for things that were not fraudulent. So here we'll say df legal. And instead of just looking for things where fraud, we can do a little tilde in front of here that should give us a negation. If you want to know why it's a tilde, I think it's technically because we're doing set logic, and so we're doing like technically your series is taking on a special form. Some people, like the first time I tried to do this, I just said not fraud, and like it seems like that should work, but no, you got to do the little tilde. And so we can look at our data frame of just legal records. And because I'm scared of my session over here crashing, I'm going to check back in. And oh, and it did finish. And I'm going to now very frantically make sure that I download some data. Okay, thank you for bearing with. Great, so we have our legal data frame, and we can look at that same value and grab the mean of that. So take a guess. Given that you know that distance from home correlates with it being fraudulent, and our distance from home of fraudulent transactions was 10 miles, 10.2, what would you say the average distance from home is for legal transactions? You think it's going to be higher or lower? Make a little guess inside your head. Or if you're playing along, you can just run the code and you can know. But so I am going to click there, and okay, 9.5. So again, these things are close, right? But 9.5 is lower than 10, right? So you are of all the legal things, they're on average a little bit closer to home. Which I think this makes sense because we probably have in this data set a mix of people just like stealing your credit card and then running over to a grocery store or whatever, but also like stealing your credit card number digitally and doing digital fraud. So it kind of makes sense that these numbers would be close, but the fraudulent ones are definitely higher. So I now am going to present to you our sort of most basic possible model, which is just saying, if you are further than 10 miles away from your home, we're going to mark that as fraud. Okay, this is like a very, very basic model. It's not going to do particularly well, I don't think, but let's give it a shot. So how would we implement this model? Well, we could say, we could be really, really simple with it. So we could say distance from home. If that is greater than 10, so we're setting our threshold. So we can say threshold. Or we can even say distance from home threshold is equal to 10. And so we're just going to say, if your distance is greater than 10, we're just calling that fraud, just always. So then let's assign that to df prediction. Boom. And now if we do df prediction.head, or actually just df head all of it, you can see we now have this new column that is our prediction of whether or not you're a fraud. And you can kind of already look here and you can see like, oh, this doesn't look great, right? Like it's not, we're predicting some things correct, but we're predicting a lot of things incorrectly. But if we wanted to get a sense of what our accuracy is, we could get our accuracy really, really easily. So we could just say, look at our predictions, and then see how often our predictions are equal to the thing we're trying to predict, which is whether or not it's fraud. And then of this whole thing, you could just take the average, right? So this is going to be 1 if they're equal and 0 if they're not equal. And so if we I think we could even just say import numpy as np. Numpy is just a numerical library for Python. It lets you do things like take averages. And so we could say numpy.mean of that. Oh, nope, did not work. key error predictions. Oh, did we just say prediction? Boom. Okay, 64%. Now, given that we just kind of pulled this number out of our ass, 64% doesn't seem that bad, right? Like, we're predicting a lot of things correctly. Obviously, if I went to a bank and I said, hey, I have this great fraud detection program, and it will get your correct prediction 64% of the time, they would like laugh in your face, right? This is nowhere near ready for prime time. But it's something. It's something. So if we wanted to actually use this prediction to submit, we'd have to actually pull out our test data frame. So if we do testdf is equal to pd read CSV, and then we can copy our test data frame. And if we look at testdf, remember testdf has everything in our data frame except for the correct label, right? So what we can do is we can use this exact same code from up here and just use it on our test data frame. So now we'll say testdf, and instead of prediction, we'll just give it that original name of fraud, right? And so now our testdf originally ended at online order. If we add this in and do head and we scroll over, we have now made an official prediction of whether these things are fraudulent or not. So we have a prediction here. So at this point, we want to get something that looks like sample submission.csv. So we've made our predictions, and if we go back over and just look at what sample CSV looks like, you can see it just has the ID in one column and fraud in the other column. So if we come back here, we could grab our testdf and only inside of it ask for the ID and fraud. And that looks pretty close. And so we could say to CSV, and we could call it submission.csv. So this is actually how you make a submission, is you write to a CSV and you title that CSV submission.csv. And I think one important detail here is you have to say index false. Let's see. Cool. So we have a submission.csv. And if we want to make sure that looks correct, then we could just say read CSV and copy that file path. Not download. We just want the file path. And we can see if this looks right. And yeah, that looks right. We have our ID in one column and fraud in the other. And we can even double check that ID 12367. Is that the same this one starts with? And yeah, 12367. So it looks like the format of our submission file is correct. And this is actually, the timing is great here. I think we can try submitting this and see if we get a score. So I will click submit. Boom. So it will now spin a little bit and submit your data, and we'll kind of see the whole arc here. And then I'll recap on how you can win swag in this competition, and then I think we'll call it a day, and we'll meet back here tomorrow. So it spins its wheels a little bit. You can see it's running, because it's running all of that code that we did, right? Which was quite a bit. But when it finishes running, we should get a score. Or it might give us an error. If we mess something up, it'll give us an error. And oh, it looks like it ran. So you can see all the output. You can see our sample submission, or our submission. And we should now be able to go to the leaderboard. I feel like it should show us our score here. I guess not. But if we go back here, we should be able to click on leaderboard, and we should see our score. Okay. Oh, okay. So our score is 0.13735. Now you may be asking, wait, Will, isn't that a lot lower than 64% accuracy? And the answer is yes. And that is a thing to talk about tomorrow. Specifically, what we're getting scored on here is different. Somebody's already submitted with a score of 0, which actually, this is a great call out here, is that I would just submit something ASAP, because it gives you a chance to get entered in for the raffle. And then you can iterate and you can try. So in fact, here I will just on this, I will publish this. I'll save a version and make it public. So now, if you want to just get a submission out there that's better than 0, all you have to do is come back and click copy and edit here, and then just click submit. And that gets a submission in, and you will be on the leaderboard. And then tomorrow we'll look at lots of ways to sort of power things up and to get better. Because it's all uphill from here, right? Or it's all downhill from here. It gets better from here, is what I'm trying to say. So I guess I will put out the call for, does anybody have any questions? Because I'm happy to field some questions about all of this. Hopefully, at this point, you feel a little bit refreshed on Python. You have a little bit of a sense for what our data set looks like, and you've noticed some of the things that kind of matter. You notice what variables correlate a little bit, and you're able to start thinking about that. And we have looked at how to build a very, very simple model that just says, if you're further than 10 miles away from your home, it's always fraud, and learn how to make a submission on that. So if all of those things kind of make sense to you at this point, then you are doing phenomenal, and you should pat yourself on the back. Otherwise, if there aren't any other questions, I will just reiterate the little prizes. So if we come over here, there are a few ways to win. One is, if you are first or second place on the leaderboard here, then you will get a swag drop, because that's impressive. Well, right now it's not impressive because there's only one submission and it's a 0. But actually, okay, there's a caveat. If your submission is well, yeah, if your submission is 0, maybe not. Oh, great question. How do we submit again? So the key here is, and I think it's easiest to look at if you just copy my code. So come over here and click copy and edit. Also, if you opened it earlier, open it again, because I just published an update. But the important thing here is that down here, we wrote, down here, we created a CSV file titled submission.csv. That's like the main thing that submits us. And then over here, you just click the submit button. So if you just copy this part 2 exactly as it is, and then click submit, then that will get you submitted and on the leaderboard. We'll look at ways to submit and get higher scores in the future, but this will get you on there. So if you get first or second place on the leaderboard, boom, that is a swag drop for you. If you are just anywhere on the leaderboard, you will be in the raffle, and so someone will get lucky, and just even if you're last place, you can win the raffle and you can get a swag drop just because you did a submission, which is great. And the two other ways you can get swag dropped are, one, by releasing your own code. So I've released some notebooks that I hope will be helpful to folks. But something else that you can do is, if you write your own notebook or change my notebook or write your own code, you can publish it. So all you have to do is, if you're editing, you can click here and click share, and you can click public. So that makes it public. And it will show up in this code section. So I will pick one person who I think released some really nice code as a notebook. And then the final one is for best conversation. So last time we did a chess competition, and it was really cool. We actually got a nationally ranked or internationally ranked chess player to leave some comments and to talk about our chess competition. And so you can do that one of two ways. You can either leave comments on notebooks, or you can create a discussion. And if you have any questions about the competition here, leave them under discussions, because that's where I will come and interact. So I will actually walk through that. So you can click new topic, and you can say, welcome to Global Hack Week. Security. Hey, friendos at Global Hack Week. We're super excited to have you participate in this competition. If you have any questions, let me know here. Happy hacking. Boom. And that gets published as a little discussion topic. So that is, I guess, 5 different ways that you can win a swag drop. And I think last time there was only one person that published code, and only one person that had a conversation, and so those people just won it easily. Is there any criteria for creating our own notebook? Absolutely not. I would say if it's just a carbon copy of one of my notebooks, probably I will not find that very compelling. But so like one person last time, they copied one of my notebooks, but they changed some of the code around and they left some comments as to like, hey, I tried this thing. So what if we, for them it was like in chess, they said, well, what if a bishop is worth more than a knight in my model? And I thought that was kind of a cool contribution. So I think you really want to, you think through things and try to add something that you find interesting. But yeah, there's no, it doesn't even have to be a submission. It could be a notebook that just says, hey, I made this cool graph, right? If you had like a cool visualization, I think that'd be like a super neat notebook. All right, there we're at. If we don't have any other questions, I will call it for the night and rest my vocal cords in preparation for tomorrow. Final call. Any other questions? I will check back in on discussions and the leaderboard regularly. Oh, one last detail is that you have 4 more days to go in this competition. So our last session is on Wednesday, or I guess 2 days from now. But you have 2 days after that to make submissions, and so I'll still be fielding questions, and then I will announce things and who won on Saturday. But thank you all for being here. Thank you, Kako Prog and Fize Magic and Cookie Monster. Y'all are lovely. It was great hanging out with you. Thank you, Lime Load. Thank you, Thomas. Okay. So much love. All right. Happy hacking, and I will see you back here tomorrow. Take care, y'all.